Hi everyone, in this video I'm taking a look at question 31 part A, which comes from one of the NEAP trial exams for advanced mathematics. I've been asked to help out with both part 1 and part 2. So part 1 says show that the equation negative a half sine 4x plus 4 cos 4x equals 0 can be written as tan 4x equals 8. And then part 2 says show that the exact value to the first two solutions to the equation tan 4x equals 8 in the domain between 0 and pi are x1 equals a quarter tan to the minus 1/8 and then x2 equals a quarter pi plus tan to the minus 1/8. So let's take a look. So for part 1 we are being asked to show that this equation negative a half of sine 4x plus 4 cos 4x equals 0, that equation essentially can be written as tan 4x equals 8. So let's look at how we can get from here over to here. I think the first step, the natural first step to do is to take this negative a half sine 4x and move it over to the other side. And that way we'll be dealing with a positive on the left-hand side and right-hand side. So let's do that. So we'll start by saying 4 cos 4x will be equal to a half sine 4x. Now I think the next thing to do is to multiply up this 2, because then we're going to end up with an 8 over here. And I notice there's an 8 in the solution, so that's kind of moving us in the right direction. So let's do that. So we'll get 8 cos 4x is equal to sine 4x. And I suspect it's at this point that perhaps a whole bunch of advanced math students might get a bit stumped, not really know what to do next. And I think the key here is to notice we've got sine and cos, yet we're looking for tan. And so you want to think, well, is there a rule that I know that links up tan and sine and cos? And hopefully if you think about that, you'll end up with, maybe I'll just note it over here. Hopefully you remember that there's a rule, probably one of the first rules that you learned when being introduced to trigonometry, that we can say tan of some angle, maybe I'll just say theta, just to be different, to talk more in general. Tan theta can be written as sine theta over cos theta. Or in other words, if you take the sine of an angle and divide it by the cos of that angle, you will get the tan of that angle. So if we want to get from these sines and cosines to tan, well, I've got a sine over here. So if I could just divide that by, in this case, cos of 4x, then I'd be looking good. But if I'm going to do that to this side, I need to do it to this side as well. So let's just say, let's divide both sides by cos 4x. So 8 cos 4x over cos 4x will be equal to sine 4x over cos 4x. Now these two cos 4x's will simplify or cancel each other, basically leaving just the 8, which is good because that's all we really wanted. And as I mentioned, this rule, tan theta equals sine theta on cos theta, we can apply that so that we can say therefore 8 is equal to tan 4x. Or in other words, we can just reverse those if we want. Therefore tan 4x is equal to 8 as required. That's what we were asked to show.
Panic boom!
So that's how you tackle part 1. Part 2 now follows on directly from part 1 because it's asking us to find the first two solutions to tan 4x equals 8 in the domain between 0 and pi. Now actually the question actually gave us the two solutions and asked us to show why they are the two solutions, but I think we can just derive them from scratch. We'll get to the same place. I think the first thing to note about tan 4x is its periodicity. So we should note that tan 4x has a periodicity of pi on 4. Now what's that all about? So first of all, the periodicity is basically the distance between all the solutions of of, in this case, tan 4x. So if you were to say chart up the tan 4x curve and draw a horizontal line at any point and count how many times it intersected with the curve, the distance between those points would be the periodicity, in this case pi on 4. Now the reason I know it's pi on 4 is the periodicity of just plain old tan x is pi, and then if you put a number in front of the x, then you divide pi by that number to get the new periodicity. So here we've got tan 4x, so our periodicity is pi divided by 4. So basically we're going to have our first solution, whatever that is, and then our next solution will be another pi on 4 across. So that's probably the essence to this part 2. So what we can do is we can find, let's just find the first solution using basic rules to solve for x, basically. So we can start by saying, let's just say the first solution is obtained by going tan 4x equals 8. Now I want to isolate x here, so the first thing I can do is take the inverse tan of both sides. So we can say 4x equals the inverse tan of 8. And then if I divide both sides by 4, I get x is equal to 1 on 4 tan to the minus 1 8. And that is what we were told to show to be the first solution. And I might just call that first solution x1 so that we can distinguish it from the next solution we're going to find, the second solution, which we'll call x2. So as I mentioned, if we know the periodicity, we can now say all the following solutions will just be obtained by adding pi on 4. So our second solution, x2, can be obtained by just taking our first solution, x1, and adding pi on 4. So let's do that. Let's substitute our x1 in. So that's going to be 1 on 4 tan to the minus 1 8 plus pi on 4. Now we can factor out a 1 on 4 here. So that's going to be 1 on 4 brackets tan to the minus 1 8 plus pi. And I think from memory it was a quarter pi plus 10 to the minus 1 8. But that's basically the same thing. The order that you add them doesn't change anything. So that is a quarter bracket pi plus 10 to the minus 1 8 as required. So that's basically it. That's how you get to the correct two solutions. The first two solutions for this tan to the 4x equals 8. So hopefully that makes sense. I think the key to it was understanding the periodicity of the curve and knowing that if you put a 4 in front of the x, then the periodicity is now divided by 4. And from there, the algebra is not too burdensome. It's just a few lines of working for each. So hopefully that all made sense and you were able to follow along with all that. And tick boom.